Hey all, welcome back to my channel, Saitri. We know that everything that we learn is all about how we learn clearly about the applications. Why? Because we should understand how it is much important to the real world, how much it is giving contribution to the real world, how it is improving the growth of our real life. That is the purpose of technology. So, how AI is going to be helpful in the real world. So in this video, we are going to see part 2 about applications of multiple linear regression in real world. Without any delay, let's get started. HR analytics. So do you ever have any ideas? Do you have any clues that how HR could use data? If you are a fresher, you just joined right now to a company as HR. If someone is coming to you and asking what will be the salary of this particular job role with this years of experience, can you tell them immediately? It is not possible, right? But if you have history of employees, you can tell them. If you know how to do data analysis, how to use AI there, how to use multiple linear regression in that. So now let's see in this problem statement how this algorithm is helping out. The first thing that you have to do is understanding the problem statement. Look into it. HR departments want to estimate salary based on candidate qualification and experience. So this problem statement is a kind of statement where you can easily understand it. But the problem here is as a fresher, you will have no clues. But just by applying this algorithm, you will get everything, every single clarity that you need to know. So for this kind of problem statement, what is something that you could predict? Absolutely the salary. That is what we have clearly given in the problem statement. You want to estimate salary based on candidate qualifications and experience. So what could be the possible independent variables which you are going to use for predict? Years of experience of a candidate or an employee, education level, skills score, location index. Now let's try to understand the columns clearly. Salary means annual salary offered. What is their CTC? Years of experience, their total professional experience. Educational level, what is their degree level? If it is a bachelor degree, master's degree, or it is a PhD degree. What is their skill score? If they have a technical skill or their communication or soft skill, whatever the skills that they do have, based on their skills, what is their rating? If I am good at coding in Java or Python or in SQL, what is my rating for that? That is what I'll be adding here. Location index, cost of living index for the city. So based on where they live, so for that, how much is they spending, how the company is getting requirements, how much the company is getting paid from their clients based on that, cost of living index of the city will be decided. So for this kind of problem statement, what could be the hypothesis? Specifically, what could be the null hypothesis? It is going to be salary is independent of experience and skills. We do have these many features, right? So null hypothesis always works in this way. Salary is independent of experience and skills. So it has no relationship. Then tell me now what could be the possible alternate hypothesis. Now let's see if you get it right or not. Salary increases with experience, education and skill level. Will it work in the same way for every kind of problem statement? No, because in 90s and all, how it worked is based on a person's experience, we can clearly tell their salary. But now it is not the same. Even Gen Zs are getting paid as same as the experience based on their skills. So skills has more relation towards the salary. So for this kind of problem, how we will be taking steps? What could be the first step that you are going to take? The first step is definitely going to be collecting the employee data set. The second step is going to be converting that categorical variables to numeric form. For example, in my data set for HR analytics, if I have 4 to 5 different job roles, for all these job roles, if I give that directly to my ML model, it can't clearly understand. Instead, if I convert them to 0, 1, 2, 3, and 4, and I feed that to my ML model, it can clearly understand. The third step for this kind of problem statement could be performing correlation analysis. So, in this process, what you will be doing? If I have 10 different columns, in that column, one column is something that I'm going to predict. So, how I'm going to predict that column? Based on all other columns that is influencing my target column, right? So, in this process, I should be predicting which column has high influence towards the target column, which columns particularly influencing more about the target column. The next step could be training my ML model. After doing all these important steps, obviously I'm going to give my data to my training model. The next step is after training my model, I need to check if my model is working or not. For that, I do have evaluation step using my evaluation metrics. And final step is interpreting coefficients. I do have so many columns that directly influence my target column, right? So keeping other columns constant, I'll be changing one particular column's value and checking which has high influence towards the target column. That's what I'll be doing. I'll be doing here at the interpreting coefficients to understand salary drivers. So this is how AI could be applied in a powerful way when it comes to salary prediction, specifically the data science and data analysis part. So multiple linear regression is so powerful because these are all the case studies. These are all some case studies where it is already being applied, but not everyone knows this. In future, if you are getting into this kind of job roles, you can definitely use them. The next application is healthcare cost prediction. Now, first thing that you have to do is look into the problem statement. Insurance companies predict patient medical expenses using demographic and lifestyle factors. So, how insurance companies are predicting patients' medical expenses based on their demographic and lifestyle factors. So, now this is the clear problem statement given. For this, what is going to be as my target variable? Absolutely the medical cost, the medical expenses. This is what I'm going to predict. Now, what could be the possible independent variables of features? A person's age, their BMI, smoking status, exercise frequency, chronic disease count. Now, let's try to decode the columns clearly. What is medical cost? This is the target column that I'm going to predict. The annual healthcare cost of a particular patient. Age of that particular patient. BMI, body mass index. So based on the BMI, we can easily calculate if this person could get obesity in the future, based on obesity, if they could get any heart disease or what. Smoking status, whether patient smokes or not. Exercise frequency, number of exercise sessions per week. It's mandatory to do exercise. Every person should do that. If they fail to do just because they feel lazy, it is not going to help them be healthy. The next column is chronic disease count. So, how many chronic diseases that person could have? They had, or if they had that particular chronic disease, if they got diagnosed or. So, that is what I'll be checking to figure out or predict the future annual healthcare cost of a particular patient. So, this is how insurance companies could use their healthcare data or their historical data from hospitals to predict if that particular person can get a medical expense or not, to get benefits in the organization and also to be beneficial for that particular person. So in this, what could be my null hypothesis? Patient's characteristics do not influence my healthcare cost. Now, what could be the alternate hypothesis then? If null hypothesis is it is not going to affect the healthcare cost, what could be my alternate hypothesis? Healthcare costs depend on demographic and health factors. So, absolutely for this kind of problems, it is going to have a relationship. It is going to influence. So, alternate hypothesis is going to work. So for solving this kind of problems, what are all the steps you'll use? The first step is collecting patient health records data set. Their health records data set could be collected from various resources, even from the patients, even from the hospitals with their permission. The second step is handling missing values and categorical variables. Third step is performing EDA, exploratory data analysis, creating charts and graphs to understand their health. Identifying key predictors of healthcare cost. In these many columns, which column is influencing more? Training my ML model and evaluating it. And the final step is interpreting the cost drivers as similar to what we have seen here. Now, the final case study that we are going to see for multiple linear regression is energy consumption forecasting, specifically in smart cities and IoT. First, try to understand the problem statement. Energy companies forecast electricity consumption based on environmental and usage factors. So, when a particular energy company is giving electricity to a particular city or a village, if they have a need of forecasting or predicting the electricity consumption just based on the environmental like humidity, the temperature and usage factors, how much they are using and they consuming. So for that I can use multiple linear regression. Now what could be the dependent variable? Their energy consumption, how much electricity they are using. So for this kind of problem statement, what could be my independent variables? What are all the columns that I'm going to use for predicting it? Temperature, humidity. Why I need to know about temperature and humidity? Because if the temperature is high, people might use more fan, more AC. If the temperature is very less, they might not use those electronic devices. So that is how these particular columns contribute more towards the energy consumption. So how population, if a particular city is having more population, they could consume more energy. Industry load, how many industries there are there on a particular city or a village? If so many industries are working based on this particular energy, they could consume more energy. Then time of day, if in morning they might not use some electronic devices, but in afternoon they might use, in night they might use. So based on that, it differs. So now let's try to understand the columns clearly. Energy consumption is all about electricity usage in kilowatt hours. Temperature is about ambient temperature. Humidity is about humidity level, the amount of moisture in the air. Population is all about number of residents, now number of people in a particular area. Industry load, it all says about energy usage from industries, from a company. Time of day, if it is a morning or afternoon or evening, how it is directly influencing my energy consumption. So for this kind of problem statement, what could be my null hypothesis? Environmental and demand factors do not affect energy consumption, but they will definitely affect it. Energy usage depends on whether population and industry load. So absolutely for this kind of problem statement, alternate hypothesis will work. So in this particular case study, what could be my possible steps to solve this problem? The first step is collecting smart meter and environmental data. The environmental data which consists of temperature, humidity should also be there, and smart meter data like for individual houses and industry should also be there. For next step for this kind of data, it will definitely be messy. So I need to clean and pre-process the data set. So the third step is performing EDA and correlation analysis to understand my data in a better way. The fourth step is training my model. Absolutely, the next step is evaluating. And finally, using model for energy demand planning. So whatever I got insights from this data, based on the insights, I will decide and I'll do planning. So the energy demand will not happen in the future. So in these many case studies that we have seen, like house price prediction, sales prediction, salary prediction, healthcare cost prediction, and finally energy consumption prediction. I believe you clearly understood how AI and multiple linear regression could be helpful in predicting the future just with data. Now you are clearly understanding how AI is powerful, how data is powerful in predicting the future. So with next amazing video, I'll meet you soon. Bye for now. We'll meet you in next amazing video.